Correlation is the association between values of one variable and values of another variable. We're going to use notation x and y for our two variables. So our data has to be in xy pairs. We use the symbol r for the correlation coefficient. And r has a range from -1 to +1. But I'm going to start with r equals 0 because that is when there's no correlation, or at least not a linear correlation. So an example of no correlation if you have just random points with really no pattern, there's not really a way to draw a line through these points that shows a relationship between x and y. They're completely random relationships, so there's no correlation. Other types of relationships that might have correlation, but it's not linear correlation, would be if you have something like a parabola formation, or you might have like a log increase, something like that. So that has a relationship between x and y, but it's not linear. Same with the parabola one. There's a relationship, but it's not linear. Correlation coefficient, at least the one that we're learning about, is only for linear relationships. So a linear relationship, the r equals 1 is a positive relationship, which means as x increases, y also increases. And that would look like something like this. So you'd have a relationship. You can draw a line through that that makes sense, that shows the relationship between the two variables. So that is a r for that set of data would be really close to 1. For r equals -1, as x increases, y decreases. And that would look something like this. So for low values of x, you'll have high values of y, and for high values of x, you have low values of y. And again, you can see there's a relationship. We can draw a line through the middle of these and show the relationship, and it's a linear relationship. So some notation for correlation. We have n, which represents the number of pairs of data, and then these other these get used in the equation to solve for r. We're not going to learn much about the equation. We're going to learn how to use our calculator to calculate r for us with two lists of data, or with means and standard deviations of two samples. So the ones that we should know about is r. Lowercase r is the correlation coefficient for a sample. And just like we have a sample standard deviation, which was s, and a population standard deviation sigma, or a sample mean x bar and a population mean mu, we're going to use a Greek letter for the correlation coefficient of the population. And the Greek letter is called rho. And it looks like a sort of a script P letter. So that's what this is right here. So it's not a P. Don't get it confused with P's that we've learned about for proportions. It's the Greek letter rho. So requirements, we need a simple random sample with quantitative data. We have to make a scatter plot and check to see if we have a linear relationship. So for all the problems we do about correlation and regression, we're going to make a scatter plot as one of our first steps. And then the next one is we have to check for outliers. The scatter plot will show if there's any obvious outliers. We could also go back and use the equation for outliers that we learned in a previous unit. If there is an outlier that you can't remove, you need to do the correlation coefficient calculation twice. Same thing when we talk about linear regression later. You would need to do regression with and without the outlier or outliers. A couple other notes about regression. When you calculate the value for r, the correlation coefficient, it doesn't matter which variable you assign as x and which variable you assign as y. But when we do regression later, we'll have a rule about which should be x and which should be y. So just keep that in mind when we get to regression. If you change all the values of a variable the same way, it will not affect the correlation coefficient. So for example, if you take the log or natural log, or if you multiply all the values by the same number or divide them all by the same number, square them or take the square root, when you calculate r with that new changed set of values, you'll still get the same value of r. Remember that we can only do this for linear relationships. And remember that we need to check for outliers. So always make a scatter plot. And then when we get to conclusions or other things about correlation here, just because there's a correlation between two variables does not mean that one of them causes the other. So don't ever talk about something causing something else when you calculate a correlation. Don't use averages. You actually have to have the full lists of x and y in order to calculate correlation. And just because there's no linear relationship doesn't mean there's no relationship. So remember, the equation and number that we're looking for is the linear correlation coefficient. There are other kinds of relationships that we are not going to be learning about, but just because r is small doesn't mean that there's no relationship. So for our hypotheses, we're going to use rho. Remember, that's our population correlation coefficient. And in our null hypothesis, we're going to say that rho is 0, which means there would be no linear relationship. And the alternative hypothesis is rho is not equal to 0, which means there would be some kind of linear relationship. Remember, if the correlation coefficient is greater than 0 on its way up to 1, it would be a positive relationship. And if it's less than 0 down to -1, it would be a negative relationship. We're going to do the p-value method for our correlation coefficient in our calculator. There is a table of critical correlation coefficients in your book. We might look at that in class, but for the video we'll just look at how to use the calculator to do these. There is an equation for t. This is the equation that your calculator would use to calculate t, and then use that to get a p-value. And the p-value is going to tell us if the correlation is significant or not. So we have an example to look at. Right, we have a list of XY pairs, and that's one of the requirements for doing correlation. We want to determine if we have a significant linear relationship, and we're going to assume this is from a simple random sample, and they give us a value of alpha. So what we do to check requirements, we have a simple random sample. It tells us that in the problem. And then what we need to do is make a scatter plot. And you could sketch one of these by hand and just have your x, come up with some scale on your x-axis and some scale on your y-axis, and then plot each point. So I'll just make some up here. So you could do it by hand, but here's how your calculator does it. And since you have to put the values of x and y in your lists anyway, you can just plug them in your calculator and then have your calculator make a scatter plot for you. So let's take a look at that. Alright, so you're going to go into Stat and Edit to put in lists. And you can see I already have the list put in here. So we have 1.8, 1.3, and so on for values of x, and then 76.4, 67.7, and so on for values of y in list 2. Make sure that you put them so that the pairs are across from each other, because they are paired data. So 1 for x goes with 76.4 for y, and 0.8 with x goes with 67.7 for y. So make sure that they're staying in pairs as you put them into your calculator. Okay, to look at a scatter plot, you can see these buttons underneath the screen of your calculator. Right above the y equals button, it says stat plot, and that's what we want to use to make a scatter plot. So I'm going to hit second y equals for stat plot. And we want to use plot 1, so we just hit enter and it says plot 1. And we have to make sure that we turn it on. So we're going to hit on, hit enter when it's on. Type, this one is the scatter plot. You can see that your calculator makes other kinds of graphs as well. One of the problems with these is that the x and y axes aren't necessarily labeled very well, so some of these other plots that we could have done earlier in the semester, I didn't show you how to do that because it's sometimes easier just to do them by hand. But we're going to do scatter plots, so that's the first option. You have to let your calculator know what lists you use. So X list was in L1 and Y list was in L2. And then you can choose whichever mark you want for your points on your scatter plot. So those are the options for the plot. Again, the most important thing is to turn it on and make sure you have the right type in your lists. Once you have all that chosen, you hit the zoom button, which is the middle button under your window. And we want to choose zoom stat because we made a stat plot and we want to zoom in on the stat plot. Hit enter. And there is our data plotted as a scatter plot. So each one of these points represents an XY pair. So X going along the horizontal axis and Y going along the vertical axis. All right. So first of all, we have to check if this is linear. And it does appear to be linear. It looks like you could draw a line like reasonably through those points and it would make sense. So yes, it's linear. Okay. Second thing we need to check for is if there are outliers. And this point right up here appears to be an outlier. It doesn't really fit the pattern of the rest of the points. This one down here, you might also question if that fits with the rest of the points, but it's not as far apart from the rest of them as this one is. So let's just consider that this one is an outlier for now and see what we're going to do. So remember, if you have an outlier, you're going to need to calculate correlation and regression with and without the outlier. So yes, there is an outlier. You might have noticed that there are no x and y values on the calculator, but you can figure out that it was the largest value of y, so it was sticking up higher than any of the other ones. So if you go back through your list of values, you want the one with the highest value of y, and that's 127.4. So this point, this data pair that I'm circling, that's our outlier. And you can see I have that written down here as well. So 1.3 for x and 127.4 for y is an outlier, and we're going to have to calculate with and without that data pair. Okay, so we've checked our requirements, we found an outlier. Our next step in solving a problem is to write our hypotheses. So our null hypothesis is always that rho equals 0, and our alternative is going to be that rho is not equal to 0. And that'll be your hypotheses for any correlation problem. The next step is to calculate the correlation correlation coefficient and a p-value with the outlier still in the data set, and then we're going to do it again in the next step by removing the outlier first. So going back to our calculator, so we put in the x and y values to get our stat plot. So we can just go back to stat and tests and we want to look for linear regression t-test, and it's toward the bottom. So if you just scroll up instead of down, you'll get there faster. So there's our linear regression t-test, and hit enter. It's going to ask where your data is. So X values were in list 1, Y values are in list 2. We're always using 1 for our frequency. Okay. This test, linear regression t-test, is also going to work for regression. And that's what this B is for. The B is for the slope of a line, and then this rho is for correlation. So your function linear regression t-test will do both tests at the same time. So for rho, we want to use not equal to 0. Okay. It gives you a spot to enter a format for the regression equation. We're not going to use that. You can just always leave that blank, and then we'll just remember what the letters stand for when we get to regression later, and then calculate. So it tells us y equals a plus bx. That is a regression line, and we'll get to that in the next video. Next one, it reminds you what your alternative hypothesis was. And now it gives you a value for t and the p-value that corresponds to that. This p-value is good for the correlation coefficient, which is what we're testing right now, and it's the same p-value for the slope, which is what we're going to be testing in regression. So it's the same p-value for both. The other value that we need is r. So when we do regression, we're going to need some of these other numbers, like the a and the b. But what we're interested in right now is r. So that goes all the way down at the bottom of the output. So it says r equals 0.8488 if you round that up. I'm just going to round it to a couple digits for right now. So I'll write down some values. We need t, 4.82. The p-value was 9.53, and if you look at the end of that number, it said e minus 4, which means we have moved the decimal place over 4 times. 0.000953 is our p-value. It gave us, I'm just going to write down a and b. We don't need those numbers until we do regression later, but we can just get in the habit of writing them down because those are numbers that are important. And the correlation coefficient, I'll just round it up to 0.85. So for right now, we're interested in the correlation coefficient and the p-value. So you can see that even with the outlier in the data set, we get a significant p-value. This p-value would be less than alpha. So we know that there is a linear relationship, because the null hypothesis says there is no linear relationship, and we're rejecting that, so we can say that there is a linear relationship. So we're going to do the same thing, but we'll remove the outlier first. So we're going to go back to our calculator and go back to our lists, so stat edit. Now, we don't necessarily need to clear the whole list and start over. We just need to remove that one point that was the outlier. So if we go over to list 1, the outlier was x is 1.3 and y is 127.4. So this is the pair of data that we want to remove as our outlier. So if you just go down and highlight the value of x that you don't want in there anymore, you have a button called DEL for delete, and you just click on that or hit it, and that deletes that 1.3 from your list. Then you have to remember to go over to your list for y and delete the same number, or the number from the same pair. So it was 127.4. We'll delete that. So now our two lists, we still have x and y in here. We just removed the one pair that was the outlier. Then we can go back to stat and tests and linear regression t-test. All these values should be the same because we didn't change anything except for removing the outlier, and hit calculate. And now you can see we have different numbers. So now the t is bigger, the p-value is smaller because it's times 10 to the negative fifth instead of fourth. We have different values for A and B, and if you go all the way down to the bottom, our correlation coefficient is bigger, which means there's a stronger linear relationship without the outlier than there is with the outlier. So let's summarize those numbers over here. And we move it over 5 times. That's our p-value. We have A and B. Again, we'll learn what those are about in regression. And the correlation coefficient, 0.93. So again, right now, this is the number we're interested for the correlation coefficient, and this for our p-value. So for a conclusion, we saw that even with the outlier in the data set, that we could reject the null hypothesis and conclude that there is a significant relationship. And to be more specific, the values of R that were calculated were positive, so we can say there's a significant positive relationship. So R is close to 1 and positive. And the p-value is less than alpha. So we had 2 pieces of information that helped us make this conclusion. The other thing that you want to do is, since we had to calculate this with and without the outlier, you kind of want to talk about how the results are different. So with both cases, with and without the outlier, we had a significant p-value. The p-value was less than alpha for both cases. Without the outlier, it was a stronger correlation. And then we also saw that the p-value was smaller. But since both were significant, either one would be fine to use, but the one without the outlier would be more accurate. And that would be true especially if you thought that outlier data point was a mistake. So if it's possible that maybe someone wrote down the wrong number when they were recording data, which would throw off that value, or if you thought maybe the source of that information or that data point was incorrect, you would want to throw it out. If you didn't know that, then again, just calculate R with and without the outlier, report both of them, and provide a little bit of discussion about having to do both with and without the outlier. So the next video we're going to look at is regression. So we're going to take this idea of looking at relationships between 2 variables and then come up with an equation that we can use to predict values. So again, correlation is just looking at a general relationship or linear relationship and whether it's significant or not. Regression is going to take it one step further and actually give you the equation of the line that shows the relationship between the 2 variables.